Okay. Hello, everyone. My name is Li Bai, a PhD candidate at the School of Computer Science and Engineering, the University of New South Wales. I'm glad to present our work entitled Adversarial Multi-View Networks for Activity Recognition at UbiComp 2020. The technical background of our work is human activity recognition, which is a significant step towards human-computer interaction and could enable a series of promising applications, such as assisted living, skills training, health monitoring, and robotics. Generally, there are vision-based and sensor-based solutions for human activity recognition. Our work belongs to the latter one due to its low cost, less invasive, and better privacy preserving ability. Formally speaking, sensor-based human activity recognition involves multiple devices attached to different parts of the human body. Each device contains multiple sensors that keep recording human movements. For example, an initial measurement unit typically contains 9 sensors that are 3-axis accelerometer, 3-axis gyroscope, and 3-axis magnetometer. Thus, our task aims to learn function f theta that classifies the multivariate time series from D sensors with sliding window T to N potential classes. In this work, we solve 2 major problems in sensor-based human activity recognition. The first one is accurate multivariate time series representation, which is difficult due to the complex spatial correlations among sensors and the temporal correlations between different time periods. The second one is the subject variance, which inherently exists in human activity recognition because people tend to perform the same activities differently due to their personal characteristics, such as gender, height, weight, and their strengths. Taking the first problem, we propose the multi-view data representation model, which extracts different spatial or temporal correlations with specific CN kernels of different shapes, including the single-time spatial correlations, single sensor temporal correlations, the multiple sensors temporal correlations, sensor at channel temporal correlations, and time at channel spatial correlations. For each view, we use a cascade CN networks, including 3 blocks to process the input data. The representation for each view are combined by a trainable Hadamard diffusion module to get the final representation of the input sensory segment. Our multi-view data representation modules is robust and can capture more comprehensive spatial and temporal correlations in the sensory schemes. To solve the second problem, to solve the subject average issue, we propose a Siamese Adversarial framework to train our data representation and classification module. The framework takes the data representation module as the generator and classify and introduce a discriminator to judge whether 2 representations come from the same person. In the training process, the MVRM tries to generate representations without personal characters so that the discriminator cannot recognize, and the discriminator tries to distinguish the representations from different persons. The whole framework works together and help the data representation module be subject invariant. To evaluate the model, we conduct experiments on 3 datasets that are mHealth, PMG2, and UCIDS, which have different scales and activity sets. Moreover, in order to overcome the bias coming from different subjects, we update the leave 1 subject out evaluation protocol to iterative leave 1 subject out, which assesses the model iteratively with left 1 subject out protocol on every subject separately. In each experiment, we train the model from scratch and test the model with 1 subject data. Finally, we will get subject number results for each model and take their average as the final performance. Our experiments have got several findings. First, our model can achieve the best performance among a set of comparison methods in the 3 datasets consistently, as shown in this figure. Second, among the 5 proposed views, we find that use the SIGCHI view, MIT view, and TCS view together is the best choice. Third, the performance of HAR models on different subjects varies significantly. Previous conclusions made with the leave 1 subject out protocol may be highest best. Besides, our Siamese adversarial training framework can boost the performance across the 3 datasets consistently. Last but not least, there are some hard to recognize activities which lead to the poor performance of human activity recognition models in some subjects. We call this phenomenon as class collapse, which should be a very important problem for future research. Okay, that's all. Thank you so much.